Alright guys, so this is lesson 2.1 and if you look at the materials under D2L, you'll have a very similar PDF with all of these slides in it. So we are going to break this up in a couple different ways. So 2.1 is going to be velocity versus time graph and graphic organizer from lesson 1. We actually did that at the end of the last video, but I'll go through it one more time. And then we'll get into motion maps or motion diagrams, which are just a different way to represent motion, and some people think that or feel like it makes it easier, so we'll do that too. Then in the second video, we'll get into reviewing graphing, so we'll practice some more position versus time and velocity versus time graphs. You guys need that practice to get better, so you're prepared for your assessment with those questions. Then we'll get into solving 1D horizontal motion problems, which is one of the, I think, first parts where it's like gets a little math heavy or a little bit more math involved. Then we'll get into free fall motion, and then we'll get into solving some free fall motion problems. So those are the end videos for this week. So just coming back to this slide, getting into the different types of graphs. Again, we studied position versus time and velocity versus time graphs. So position versus time just display location at a time. So it's pretty simple. It's just telling you where an object is located at a certain point in time. On the vertical axis, position is in meters, and time is in seconds. The meaning of the zero, so if you had values for x is equal to a positive number, or x is equal to a negative number, or x is equal to 0. If it's a positive number, that means you're to the right of the origin. Trying to shrink this and make it fit into the box. All right, so you're to the right of the origin, so positive just means right of the 0. If x is equal to a negative number, then I'll use a colon instead of a dash because that gets confusing with the negative. It's just the opposite, so you're to the left of origin. And then finally, if you are x equal to 0, that would be x equal to 0 meters generally, that means you're at the origin. So you're at whatever we have established to be our origin. For the slope of the line, slope is just rise over run. So it's the change in position divided by change in time. That's very big. So again, I'll shrink this. I don't know why it defaults to such a big value. And the change in position divided by the change in time, that is known as our velocity. So it actually tells you the velocity. The slope of the line tells you the velocity of the object. All right. And then for the last one, you don't have to worry about that box. So there, we didn't calculate any areas between the x-axis and the line on a position versus time graph. So that one you don't have to worry about. Going on to the velocity versus time graph. Again, starting here a little smaller. It shows you velocity, which is position. I'm sorry, it's the rate of displacement at a certain time. So it's kind of the speed with the direction. Velocity is measured in meters per second, and I'm going to say plus or minus meters per second, because again, the positive and negative mean a certain direction. So positive is right, negative is left. And then time again is measured in seconds, so I won't rewrite that. Meanings for zeros. So let me copy this and just change some stuff out. Maybe not. Sorry, I thought that would be easier. There we go. So if you have a positive velocity number, that means you're moving right. And that's it. It doesn't tell you where you're located. The velocity doesn't tell me I'm at a certain position. It just tells me in which direction I'm headed. If your velocity is a negative value, it means you are moving left. And if your velocity is 0 meters per second, just like in your car, if you're going 0 meters per second or 0 miles per hour, you're stopped or not moving. Okay. Slope has another meaning here, so it is not the same as there we go. It is not the same as a position versus time graph. It is showing the change in velocity divided by the change in time, and this is known as the acceleration. So it's measuring how quickly you are changing your velocity, which is a big concept that we have talked about in other videos and we will talk about again later. Finally, the meaning of the area between the x-axis and the line. Oh, I misspelled velocity. Let me fix that. The area that is the displacement. So displacement, again, measuring how much you have changed your position. That is what the area tells us. So you might want to keep this handy as like a note sheet that you can refer back to when you're working through either position versus time graphs or velocity versus time graphs, so you can refer back to it and get some information on it. Okay, so we're going to jump into kind of a new way to represent motion, which is something called a motion map. So in a motion map or a motion diagram, it represents the motion of an object with a dot. So the object is the dot, and then the velocity is an arrow. And every second of time that passes in the motion is represented by a new dot with a new arrow. Okay, so if we take a look at this basic motion map here, the first dot is here. So let me write a little bit. So this is the first dot, and I'm going to say that occurs at time equal to 0 seconds. And we're going to just say every dot represents a new unit of time. So this would be like 1 second of time, and then 2 seconds of time, and 3 seconds of time. Sorry, I'm trying to write with a mouse, which is a little bit difficult, and 4 seconds of time. And as you can see on the scale below in the diagram, it tells you, or it shows you the location at different times, so we can read off the graph at 0 seconds or 1 second, 2 seconds, 3 seconds, 4 seconds. So that's what it's asking you to do here. So we're not going to write yes or no. We're actually going to write down the value. So at position at time equal to 0 seconds, we're at 0 meters. So that is our location. So 0 meters is our location X for all these. So X equals, and this one's 0 meters. At 1 second, you can read off it's at 2 meters. At 2 seconds, it's at 4 meters. At 3 seconds, it's at 6 meters. That's supposed to be a 6. And at 4 seconds, it's at 8 meters. The last question is just to make sure you understand, like, maybe the graph or the motion map doesn't show all of the information that you can answer every single question with. So at position at 5 seconds, I don't know. There's not a fifth dot, so I don't know where this object is at 5 seconds time. So I'm just going to put a blank there and say that I can't answer it. That also means I can't tell about the velocity at that time as well. So coming back to velocity, an idea with velocity, velocity is equal to the change in position or the displacement divided by the time. So we can figure out displacement on this fairly simply. So all we have to do is look at the change in position between two dots and divide it by how much time goes by in those that time interval, whatever length of time that is. So so velocity at 0 to 1 second of time, I'm trying to figure out how fast it's moving. So it's, again, just kind of filling this in. So if I look at, this is my final position in that time interval, so that's xf, and this is xi. And we did this a couple of videos ago, but we just need to take the difference to get the displacement. So it would be 2 meters, positive 2. I'm going to be, these should all be positive values here just to specify direction, because it's at a specific location. So positive 2 minus 0, and we're going to divide that by the time interval, which is 0 to 1 second, so 1 minus 0. So 2 divided by 1 is just 2. That's meters per second, and it's a positive. So remember, the positive doesn't mean that it's speeding up or slowing down, it just means the direction. So it's going to the right, and it looks like between 0 and 1 seconds it's moving at 2 meters per second, because it goes from 0 to 2. So we would continue to do that for each time interval, so from 1 second to 2 seconds, 2 seconds, 3 seconds, 3 seconds to 4 seconds, and it's going to be the same value. So this is moving at a constant velocity, and you can tell that on this kind of motion map diagram, because you can see that the dots are equally spaced apart. So there is an equal amount of space per time, so all these dots are equally spaced apart, and they're all occurring in the same time interval, so that means they all have a constant velocity. Now if the dots got further stretched apart or closer together, that's obviously going to change the velocity, and then you would have to calculate different velocities. Okay. So that is the first one here, and we'll go on and kind of show how we can work between the two different types of representations of motion. So we have a standard position versus time graph here. We're going to write out in words what it means, and then we'll draw the motion map over here. So try to figure out what's going on. So if we take a look at this, I'm going to put some dots on here just so we have some references, sort of like when certain things, it makes it easier to read the position at a certain time. So let me get the pen that I want. That's too small. Getting better. There we go. All right. So 1 second, 2 seconds. So I'm just trying to put a smiley face at each second that we have. Okay. So it looks like our time axis goes from 0 to 8 seconds, and our position goes from 0 to, it looks like, positive 4. And we're going to describe the motion of the object in words. So I'm just going to type out kind of what I see happening in these in this diagram. So so I would say the object starts at 0 meters, because that's the initial position, and moves to, so going from here to up to here, it looks like it moves to positive 4 meters from time 0 to, it looks like 2 seconds. So it looks like that's what's happening in this first part of the motion. So it starts down here at 0, then it moves to 2, then it moves to 4, and that takes a total of 2 seconds. Then the next section here, I would say, is from 2 to 3 seconds, this horizontal section here. So the object remains at positive 4 meters from, looks like 2 to 3 seconds. The next one, I'll move this up a little bit so we can see it a little better. The next one, I think, is this section here, where it looks like the line is moving down from, it looks like, positive 4 to 0. So the object moves from positive 4 to 0 meters from, it looks like, 3 to 7 seconds. And then finally, the object is stopped and remains at 0 meters from 7 to 8, not 9, 8 seconds. So all I'm doing is kind of representing this motion that I see displayed on this graph in 2 words. And I think a lot of people find that helpful to try to get a better understanding. If you just look at it as a graph, that sometimes confuses people, but if you think about it as an object moving, then that kind of helps out. We've worked with these position time graphs again, so this is a little bit of a review of that, but let's kind of take it and move it to a motion map, or the little dots here. So I'm going to put these dots at the different positions on this horizontal axis. So the first dot I'm going to put is at 0 meters, because that's the first one, which is at 0 seconds. The second dot, it looks like at 1 second of time I'm at 2. So if that's 0 and this is 5, that'd be 1, 2, 3, 4, 5. So I'm going to be at 2 meters here. And then for this one, I'm at 4 at 2 seconds. So that seems to check out. And I'm going to have some arrows. Okay, and I'm going to have the arrow going to the right. So that looks like what's happening there. So I've done these first 3 dots. The 4th dot here, it's staying at 4, so I'm going to shoot. Hold on a second. Alright, so I'm trying to recover where it crashed a little bit, unfortunately. So again, we've kind of put these dots on already. So 0, 2, and then 4, and we drew in the arrows that moved to the right, going from 0 to 1 seconds and 1 to 2 seconds. So now we're at this position here, so maybe I'll change the shape and that'll help distinguish it. So let me get back to a pen. And let's say we're here. So it's staying at 4 seconds, so I'm just going to put that there. And then I'm going to change the image again on the way back down. So then I'm going to mark seconds here. So it looks like, so that's 0, 1, 2, 3 seconds. At 4 seconds, I'm at 3 meters. Then 2, then 1. And then 0, so this would be 1, 2, 3, 4, 5, 6, 7, 8, or let me see. Yeah, so I think that's okay. So so this should be 7, and then I think that's 8 here. There. All right, so that's the motion map of it. So again, just kind of looking at it, so the object's moving to the right here, where it has a positive velocity or positive slope. It has no motion here, that's where it stopped. And then it starts moving with a negative slope, so it's moving with a negative velocity back to the left, and then it stopped again here at the end. So we've indicated that. Let me draw on these arrows. What you should notice, so it didn't move there, and then it's going to the left here, and you notice that the space between these, and again stopped kind of going there to there, the space between these different marks is smaller, so it has a lower displacement, which is what we would expect. Okay, so hopefully that makes sense. We already described the motion in words. I won't retype that. Another one here, just showing you can work the opposite way. So we have our motion map. I'm going to just label these with, so this is our beginning. Oh, I don't want to use that. So this is like 0 seconds, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. And if we're describing in words, I'm just going to talk it through. So it looks like it's beginning at positive 5 meters, and the object moves to the left between 0 and 3 seconds, and it moves from positive 5 to, this is like positive 2. Then it stops for a couple seconds, and then it moves from positive 2 down to 0, and it stops at 0, and then it starts moving back, and it ends at, it looks like positive 4 at the very end. So we could graph that, and that's what I'm going to try to do here. So I'm at positive 5 in the beginning, and then it looks like it's moving 1 meter per second for the next 1, 2, 3 seconds. So that seems to check out. We've gotten to positive 2 meters at 3 seconds. That's good. Then it stays at positive 2 for 4 and 5 seconds. Then it continues to move to the left from 5 to 7 seconds. So at 6 seconds, it's at 1. At 7 seconds, it's at 0. So I'm just plotting the points. 8 and 9, it's at 0. And then 10, it's at 2. And it looks like at 11, it's up to 4. So again, we can kind of put in the lines here. So it's going like that, and then across, down. So that is the general like line, what it would look like. So again, negative velocity, so it's moving left. No velocity, so it stopped. Another negative velocity, moving left, stopped again, and then positive velocity means moving right. And we can calculate all that speed and everything if you want to. All right. So I didn't write out all the steps to that, but that's okay. All right. So I'm going to do one more, and then we will stop. So this is a velocity versus time graph, and then we will kind of practice some of these position versus time and velocity versus time again. So actually, I'm going to skip this one. So we'll skip over this one. This video is 20 minutes already, so I'll stop there. Hopefully it was helpful, and be well.